Okay, number 3 wants us to solve some systems of equations by using substitution. Now, the first one is actually very easy because we already have both y's equal, right? Both of them are already set equal to y, so this is one of those examples where Malik's method, very easy. You can use Malik's method. So you can take these two and just set them equal to each other because basically I'm taking this y out, I'm putting this in for it, right? So I can just say, oh, that's 5x plus 2 equals negative 2x plus 9, right? This is set up to make Malik's method easy. So then from there, once you set them equal to each other, you've gotten rid of the y. Now you need to find out what x is. So I'm going to add 2x to both sides. That's 7x plus 2 equals 9 because these cancel. Now I want to get the x alone, so I'm going to get rid of this. I want to subtract 2, but what I do to one side, I have to do the other. That gets rid of this, leaving 7x on this side equals 7 on this side. And now 7's being multiplied by x, so to undo that, I divide by 7 on both sides. So x equals 1, but am I finished? No, because I still need to know what y equals. So I take the x, and I put it back into one of these equations, and it doesn't really matter which one. So I'm just going to pick the top one. So I'm going to take y equals 5 times 1 plus 2. See how I plugged it in? 5 times 1 plus 2. And now I don't have to do anything but evaluate. 5 times 1 is 5, and that equals 7. So my point is 1, 7. X equals 1, y equals 7. Now the next equation is not quite as easy. We've got x equal to something here, but then we don't have any variables alone here. But what's nice about that is still we have x by itself in one equation. So that still saves us some trouble. We don't have to get a variable alone. So we've got x by itself in the first equation, so we just follow our flowchart. We take out what x is, and we put in this 3y minus 2. So I'm going to rewrite this equation exactly as I see it, but where I see x, the magic moment, I can take the x out, and I can put 3y minus 2 in. That's the substitution step. It's like removing $1 and putting in 4 quarters. So I see x, but I'm not going to write x. I'm going to write 3y minus 2, right? But then everything else I need to write the same. I need to write the minus sign. I need to write the 3. I need to write the y. I need to write the equals, and I need to write the 4. So this equation looks just like this equation, except where x was, I put 3y minus 2 because they're the same. Now I have an equation with just y's in it. So I can solve for y. Now there's no distributive property to do here because there's no number in front, so I can actually just remove the parentheses. And, oh wow, I'm just realizing now that this has a mistake in it. So I actually wanted this to say 4y. So we're going to do that. We're going to call that 4y right there. So I apologize for that. If you correct that, please. 4y. Okay, so now we're going to combine like terms. 3y minus 4y is negative 1y, right? So these are like terms. Combine them. They're on the same side, so we can combine them. There's still a negative 2 here, so a negative 2 equals 4. And you guys remember, when you have a minus sign in front of something, that's the same thing as plus a negative. So keep the negative sign with it. This is 3 plus negative 4 is negative 1, and this is a negative 2, right? Now we need to get y by itself, so I need to get rid of this. I need to add 2 to get rid of it, but what I do to one side, I do to the other. So that leaves negative 1y on this side equals 6. And then I just divide this side by negative 1 to get rid of that. So y equals negative 6. But I'm not finished because I only know y and I need to know x as well. So I'm going to take it and I'm going to plug it back into one of my equations. Okay, now one of my equations, it doesn't matter which one, but I think this one's going to be easiest because x is already solved for here. So I'm going to take x equals 3, but instead of writing the y, I write a negative 6. This is substitution, and then minus 2. So I write everything the same except where I see y, I put in a negative 6 instead. And now I can just work this out. X equals negative 18 minus 2, and that equals negative 20. So now I know x equals negative 20, y equals negative 6. This is my solution, right? Last one one doesn't have any variables alone. So I have to pick which variable I want to get alone. Now, I could pick this x, I could pick this y, I could pick this x, and I could pick this y. And I am going to pick this x. And the reason is it doesn't have a coefficient, which means it's going to be easier to get alone. I won't have to divide by anything. Okay, so since this x is all by itself, I'm going to take this equation and I'm going to get x all by itself by subtracting 12y from both sides. If I subtract the 12y, these will cancel. That will leave x here, and these are not like terms, so I just write out 8 minus 12y. So now this becomes a problem very much like b, right? I have x by itself in the second equation, so I go back to the first equation, and I write it out just as I see it, except where I see the x, I'm going to put in this. So I'm going to write 8, but now I see an x, so I'm going to put in 8 minus 12y instead of writing the x. That's the magic moment of substitution. And I'm going to keep writing the equation just the same. I see a minus, I see a 2, I see a y, I see an equals, I see a 15. So notice the only thing I changed was when I saw an x, I didn't write x. I wrote 8 minus 12y because that's the same thing as x. Now I have an equation where I only have y's and I just need to solve them. So this one requires distributive property. I've got 8 times things in parentheses, so I need to distribute first. So 8 times 8 is 64. 8 times negative 12, that's 96. And then y, 96y, minus 2y equals 15. Now I have like terms to combine. Negative 96 minus 2, so 64 minus 98y equals 15. Now I need to subtract. I need to get the y by itself, so I need to subtract 64 from both sides. Okay, so that cancels, leaving negative 98y equals, and then 15 minus 64 is negative 49. And then from here, I need to get the y by itself, so that means divide by 98, divide by negative 98, divide by negative 98. And that's y equals positive 1/2 or 0.5. It's your choice. I'm going to go decimal. Okay? So y equals 0.5, but I'm not done. I only know what y is. I need to know what x is. So I need to take this and plug it back into one of the equations. And it doesn't matter which one. I actually have 3. I have this equation, I have this equation, and I actually have this one down here where I got x by itself. So to be honest, I'm going to use this one because x is already by itself. So I might as well use this so I don't have to use any algebra. I'm going to take this and plug it in. So x equals 8 minus 12 times 0.5, and I just have to work that out. 12 times 0.5 is 6, and 8 minus 6 is 2. So my solution is x equals 2, y equals 0.5.